Yeah, please take the question, ma.
Yes, sir.
What is the minimum energy of one photon?
What is the
What is the minimum energy of one photon
yes, sir.
that can produce photon, not proton, PHOTON,
Yes, sir.
that can produce electron positron pair?
Sir, that can produce photon, electron, positron pair.
I am reading it once again. What is the minimum energy of photon that can produce
Yes,
an
sir.
electron positron pair?
Positron pair. Yes, sir.
Also find the wavelength of photon used.
Also find the
The wavelength of photon used.
photon used.
Yeah. See, if you have nuclear physics idea, you can directly tell the answer. But I'm giving you the method of solving it. You know, gamma ray photon splits into an electron and positron.
Electron and positron. Yes, sir.
This is called, what do you call this phenomenon? Huh?
Nuclear fission. Nuclear fission, sir.
No, see what I have written on the board, read it out.
Pair production.
Nuclear fission is different. Uranium nucleus splits into barium and krypton. Yes or no? A single
Yes, sir.
nucleus splits into two different nuclei there.
Yes, sir.
Whereas here, it is a particle inside the nucleus, gamma ray photon.
Yes, sir.
So it's splitting into pair of two particles having equal masses, same charge, but of opposite kind.
Yes,
Yes
sir.
or no?
Yes, sir.
So here it is the mass of each particle is m, correct?
Yes, sir.
So what is the rest energy? M naught c square for one particle, correct?
Yes, sir. Yes,
So
sir.
you have two particles each of mass m naught.
Yes, sir.
So what is the total energy mass?
2m0 c square.
Okay, 2 into m naught is how much?
9 into 10 to the power of minus 31
1
into 3 into 10 to the power of 8
whole square. So
into 3
9
into 10 to the
into
power
10
of
to the power of 16. Correct? Huh?
yes, sir. 9 to sir 18. 18.
Yeah. 162 into 10 to the
8
power
9
of,
sir 22. Yes, sir.
yeah, let us put 16.2 into 10 to the power of
20
minus
10 to the power
16.
of minus 25.
Minus,
10 to the power
yeah,
of 8.
10 to the power
10
of
to the power
minus,
of minus 25.
minus 16, right? 16.2, 162, na? 162 into 10 to the power of minus
Yes, sir.
15, minus 15. So 16.2 into 10 to the power of minus 16
Yes, sir.
joules.
16. Yes, sir.
So 16.2 into 10 to the power of minus 16 by 1.6 into 10 to the power of minus 19 in electron volts. Correct?
Yes, sir.
So this will be 1.02 into 10 to the power of 3.
1.6, 16.2. Yes, sir.
So you'll get 1.02 million electron volts. You have to remember this number.
Yes, sir.
Yeah, if a gamma ray photon of energy 1.02 million electron volts splits into positron and that particle will, the particles produced are positron and electron, correct? Now, you wanted
Yes,
the
sir.
wavelength, right? Yes or no? So, wavelength is
Yes,
equal
sir.
to hc by lambda. So, lambda is hc by E.
E is equals to FC by lambda.
Is it right? So,
Yes,
hc
sir.
value
10 to the power of minus 54.
12,400 into 1.02 into 10 to the power of 6 million electron volts to electron volts.
Yes, sir.
So this is 10 to the power of
Yes,
6,
sir.
1.24, 10 to the power of minus 2. So 1.24 by 1.02 into 10 to the power of minus 2 means it will be around 0.012 angstrom units. Zero point zero 0.012 angstrom units. Correct? Got it, ma? It will be 1.2 into 10 to the power of minus.
Not visible.
What?
Yes, then out again came, sir.
Your voice is not clear, right?
Sir, meeting went out and only came, sir, before a few minutes.
You're not able to see the screen?
No, sir.
Are you seeing the screen, ma? Hello? Hello?
Sir?
Yeah, are you able to see the
Hello, sir.
screen?
Nothing. No, sir. Only black screen only coming, sir.
Now? Are you able to see, ma?
Now okay.
You're able to see the
Now
screen?
okay, sir.
Okay. So this is, what is the
Yes,
simplified
sir.
value of it? 1.2 into 10 to the power minus 2, correct? If you simplify this is the answer. So it will be 0.012 angstrom units. Correct? Huh?
0.01 grams. Yes, sir.
Yeah, take the
Yes, sir.
question.
Yes, sir.
Find the ratio of de Broglie wavelengths. Find the ratio of de Broglie wavelengths of hydrogen. Find the ratio of de Broglie wavelengths of the molecules of hydrogen and helium. Molecules of hydrogen and helium at temperatures of 27 degrees centigrade and 127 degrees centigrade. Find the ratio of de Broglie wavelengths of molecules of hydrogen and helium which are at temperatures
Yes, sir.
27 degrees centigrade and 127 degrees centigrade respectively. So how will you solve this? I gave you one formula for de Broglie wavelength.
Yes, sir. Lambda is equals to h by root over 3m kb into t. That's our.
Excellent. Very good. 3m kb into t.
kb into t.
In that, h and kb are constants, correct? Yes or no?
Yes, sir.
So lambda h by lambda
Yes, sir.
helium is root of mhe by mh, the by th. Correct? Is this relation
Yes,
correct,
sir.
ma?
Yes, sir. Correct, sir.
Yeah, come on, substitute and tell me the answer.
Hydrogen. Temperature 127 by root over 127 by 27.
Root over 127 by, I'm writing here, 127 by, what about masses, ma?
27 into
Mass of helium, 4mh. Mass of hydrogen, mh. Have you put this answer? Correct only? Swarna?
three something will come, sir.
Ma?
Hello,
Hello?
sir.
Yeah. You're able to see?
27 into 4.
Some problem with
Yes,
your network,
sir.
ma. Some problem with your network. I'm not able to hear you.
Full net only it is showing, sir.
Are you able to see this step? This step, could you see?
Sir, this yes, sir. Yes, sir.
Yeah. Is it correct or wrong?
Sir, correct only, sir.
Wrong, sir. Why it is wrong, sir? Because capital T means temperature in Kelvin scale. Correct, na? Yes or no? Swarna, it should be temperature in Kelvin scale. Correct?
Yes, sir. Yes, sir.
So what should you do? It should be
We have
127 plus 273 by 27 plus 273.
273 into 4.
So 2 into, this is 400 by 300. Correct?
Yes, sir. 400 by 300.
So it is
4
2
by
root
3.
2 by 3. Correct?
Yes, sir.
See? What silly mistake you did. Correct or not?
Yes, sir.
Yeah, this temperature
Yes, sir.
should be in Kelvin scale. Should not directly substitute the centigrade temperature there. Okay?
Yes, sir.
Yeah. Let us do one more.
Sir, 270 is one root over 400 by 300
Yeah.
into 4, no, sir.
Yeah.
4 16,
Yeah.
4.
Yes. You're right. I put 2. Good. So it should be 2 is to 4 is to 3. Yes, you're right.
Yes, sir.
Good. Yeah. Shall we go to next?
Yes, sir. Sir,
Anything?
4 root under 3 only, no, sir. 3
Yeah,
is
4.
under root only, no.
Correct. You're right. 4 root 3. Absolutely right.
Yes, sir.
Yeah, take the next question.
Yes, sir.
Problems are good, eh?
Yes, sir.
Hmm. That's what I'm telling. Don't do separately. You can practice the same models with changed numericals, right? Yeah, you just
Yes,
try
sir.
this tomorrow and let me know, because it's a JE model question. NEET has no scope, but still, because of its importance, I'm telling you. I'll tell you the method. You try it afterwards. Okay?
Yes,
Find the number of photons. Find the number of photons.
yes, sir.
Find the number of photons
Yes, sir.
of radiation of wavelength. Of radiation of wavelength
Yes,
5,000 angstrom units. Already we did one model. This is little more force concept. I gave that formula also. 5,000 angstrom units.
sir. Sir, meeting went out often, sir. What's the reason, sir?
Meeting went off.
It went, out of the meeting, sir. What's the reason, sir?
Which went out of the reason, ma. You are shown in this, in participants, you are visible here.
Now, first a few minutes were dictating after radiation of wavelength, it went out, sir.
Now you are able to see.
Now, okay, sir.
Yeah, you have the problem with your net, ma. So your net is very
Yes,
slow.
yes,
Yeah,
sir.
I request Dari to put that info net. That's good.
Yes, sir. Yesterday only he put that also, sir.
Info net he put.
Yes, sir.
No, in our house it was good. I don't know what happened to you. So just check it.
Yes, sir.
Okay, because many people will be using it now, na? Office timings.
Yes, sir.
Early morning
Yes,
is better.
sir.
Can you, shall we plan it early morning?
Yes, sir. For me, no problem, sir.
At-
Daily morning 8 to 9 exams also is there.
No, early morning means before 6.
Yes, sir. No problem, sir.
I'll plan and let you know, okay?
Yes, sir.
Yeah, fine. I'll inform you. Good. If you are ready in
Yes,
the early
sir.
morning before 6, we can have wonderful class.
Yes, sir. No problem, sir. For me.
Yeah, I'll inform you. I'll plan it and inform you, right?
Yes, sir.
Fine, fine. You take this problem. 5,000 angstrom
Yes, sir.
units must fall per second.
Yes, yes,
Must fall per second
yes, sir.
on a black plate. On a black plate
Yes, sir.
to produce a force of
Yes, sir.
6.62 into 10 to the power of minus 5
6
newtons.
months. Yes, sir.
Into 10 to the power of minus 5 newtons.
Yes, sir.
Find the rate at which find the rate at which
Yes, sir.
the temperature of the plate will rise. Find the rate at which the temperature of the plate will rise
Yes, sir.
if the mass of the plate is 19.8 kilograms and specific heat is and specific heat is 25,000 25,000
Joule Kelvin.
Yeah, here I wrote the units. Joules, kg
Yes.
inverse, Kelvin inverse. 25,000 joules, kg
Yes, sir.
inverse, Kelvin inverse. Look here, first bit. You know, momentum of a single photon, h by lambda, correct?
Yes, sir.
Set a number of photons per second are striking it. So it is n by t into h by lambda, correct?
Yes, sir.
Yeah, this is delta p by delta t per second. Now, force exerted by this radiation. Yesterday I told you, whenever you keep your hand under sun, when the sun radiation is falling
Yes,
on your hand, you will feel some physical sensation because the radiation falling on your hand will exert force and it will also uh, exert some pressure. That's what I told you other day. So
yes, sir.
this is the force. So how much it will be? N by t into h by lambda.
Yes, sir.
So what is asked here? Number of photons per second. N by t is asked. So f by h by lambda. Correct, ma?
Yes, sir.
Yes. So now, uh, can you do the calculation?
Yes, sir. I'm doing only, sir.
Yeah, these many photons per second will be the answer.
Yes, sir.
You will be getting around 5 into 10 to the power of 22 is the answer. Will you do the calculation afterwards?
Yes, sir.
Okay, fine. Now, so what is the energy equivalent? Energy equivalent is, yes, it is equal to n
MC
into
square.
hc by lambda. Lambda is there, na?
Lambda. Yes, sir.
N by t into hc by lambda. So it is 5 into 10 to the power of 22 into 12,400 by lambda 5,000. You will be getting some electron volts, correct?
Yes, sir.
Convert this into joules. It will be 19,890 joules second inverse.
98.
Simplification, you please do it afterwards, okay?
Yes, sir.
And this is nothing but the amount of heat energy falling per second. Whatever energy that is falling on the plate is being used for heating it. Because in
Yes, sir.
yeah, in transmission of heat in 11th class you might have studied that black surfaces are the very good absorbers as well as good radiators of heat, correct? So
Yes, sir.
all this energy of sun will be converted into heat, correct?
Okay, sir.
But what is
Yes,
the
sir.
formula for H? Is it not ms into delta T? Mass into specific heat into rise in temperature, correct? Specific heat
Yes, sir.
capacity, calorimetry last year. So, amount of heat per second,
Yes, sir.
dH by dt means ms into d capital T by d small t. What do you mean by this, Ray? This means rise in temperature per second, correct? Yes or no?
Yes, sir.
So this is asked in the problem.
Yes, sir.
Means dt by d small t is equal to s dH by dt by ms. So how much value got dH by dt? It is 19,890 divided by mass is 19.8. Specific heat is 25 into 10 to the power of 3.
Yes, sir.
Hmm. So if you simplify, you will get the answer.
Yes, sir.
19.8 into 10 to the power of 3 will cancel with this, nearly, approximately. So 1 by 25 means 0.04 degrees centigrade per second is the answer.
Yes, sir.
Understood?
Yes, sir.
Okay. One more. Because compulsorily questions are being asked in need. That's why I'm throwing more focus. Photoelectric effect,
Yes,
many of
sir.
the students will attempt, but dual nature, many of the students are failing to answer because they don't work more on that.
Yes,
So
sir.
if you practice what I am doing for the last 3 days, this fourth day, it is enough for your NEET exam. But practice is very important.
Yes, sir. Sir,
Ah,
formula I can apply, sir, but calculations only.
your calculation speed will come only with practice, ma. Understand?
Yes, sir.
And more you practice, the
Yes, sir.
speed of calculations will increase. Yeah.
Yes, sir.
Next, a particle of mass m a particle of mass m is confined is confined to a narrow tube of length L to a narrow tube of length L.
Yes, sir.
Find the wavelength of find the wavelength of the de Broglie wave. Find the wavelength of the de Broglie wave
Yes, sir.
which will resonate in the tube.
Yes, sir.
Also find also find the momenta and corresponding energy. Also find the momenta and corresponding energy.
Yes, sir.
See, you need the knowledge of um, stationary waves in a rigid string. You need the knowledge
Yes,
of
sir.
it. This is the string stretched between two supports. When the particle
Yes,
inside it is moving, waves are produced. Correct?
yes, sir.
So at the two rigid ends, what can be formed? Node or antinode? Huh? At the open end,
And no,
huh? At the
at no
open
option.
at the open ends, antinodes are formed. At the closed ends and fixed ends, nodes are formed. Correct?
Yes, sir.
So, what is the least possible mode of vibration? Like this. Yes or no?
Yes, sir.
So, this is L and this is equal to lambda by 2. So, lambda by 2 is equal to L implies lambda is equal to 2L. Correct?
Yes,
Yes,
sir.
sir. Suppose if n number of waves are formed, then total length is L, correct? Yes or no, ma?
Yes, sir.
So how many waves are formed? N waves are formed. N into lambda by 2 is equal to L. Therefore, lambda becomes how much? 2L by N. Assuming
Yes,
that
sir.
assuming that n waves are formed. N can take the values of 1, 2, 3, 4, etc. Yeah, today you have to read the stationary waves in stretched string, one end closed pipe, open argon pipes. Then you will understand this question.
Yes, sir.
But because you want to write JE also, very important modalities. Even NEET also they can ask
Yes,
this.
sir.
Formula, very important
Yes, sir.
formula. Okay. So remember,
Yes,
I will explain you after this. Just I will try to remind you what you have studied in argon pipes and those things. Therefore, this is lambda. And you know, lambda is equal to
yes,
H
sir.
by P. Therefore, Pn corresponds to H by lambda n. Am I right?
Yes,
So
sir.
how much it is? H by, what is lambda n?
Two
Simple.
L.
H by lambda, na? Logically how to remember it?
Yes, sir.
You cannot do all these things in the exam, correct? Therefore,
Yes, sir.
P is equal to H by lambda. Pn is equal to NH by lambda. Finish. Lambda is 2L.
Yes, sir.
Lambda is 2L.
Yes,
Single step. Shortcut, which all of you will like.
yes, sir.
No concept, but only
Yes, sir.
shortcuts. What I explained here is
Yes, sir.
concept. What I explained here is concept.
Yes, sir.
This is shortcut. Okay?
Yes, sir.
Yeah.
Yes, sir.
Don't feel bad, huh? Many of
No,
you
sir.
like
No, sir.
many of you like shortcuts, na?
Yes, sir.
Ah. So kinetic energy, momentum are related by the formula
N,
Pn square by 2m. P square by 2m, re. Kinetic energy momentum relation. K is equal to P square by 2m. So it is Pn square by
Yes, sir.
2m. Means how much? N square H square by 8ml square. Please check.
N square L H by lambda. Yes, sir.
Am I right?
Yes, sir. Correct.
Here in both the cases, you can find n is equal to 1, 2, 3, 3, etc. in the options. Multiple options. There may be n is equal to 1, 2, 3, n is equal to 1, 3, 5. Like that, they may give you options.
Yes, sir.
Yeah. Any doubt in this?
No, sir.
Yeah. I'll just remind what you already studied in stationary waves. Just try to read today. Then you will understand this problem in a better way. Okay?
Yes, sir.
Yeah.
Yes, sir.
This is one end closed argon pipe.
Yes, sir.
This is open argon pipe. Here is a
Yes,
stretched
sir.
string. Correct? Huh?
Yes. Yes, sir.
And this is how stationary waves are formed on one end closed pipe.
Yes, sir.
And this is how stationary waves are formed in open argon pipe.
Yes, sir.
This is how stationary waves are formed in string.
Yes, sir.
So here, this is antinode. Correct? Huh?
Yes,
This
sir.
is
That is
node.
no.
So L is equal to distance between an antinode and node is lambda by 4. So lambda is equal to 4L.
Sir, how distance between antinode and node is lambda?
Yeah, in stationary waves, that's why you have to read it. Then you'll understand.
Yes,
In stationary waves, distance between two alternate nodes
yes,
or
sir.
alternate antinodes.
Yes, sir.
Alternate antinodes will be equal to lambda.
Yes, sir.
Distance between alternate antinodes or alternate nodes is called the wavelength lambda.
Yes, sir.
So here one antinode and node is there. Therefore, it should be lambda by 4.
Lambda.
This is lambda by
Yes,
2,
sir.
right?
Understood.
This is lambda by 2.
Yes, sir.
So it should be lambda by 4.
Understood.
Now,
Yes, sir.
distance between adjacent antinodes, how much it is?
Lambda by 2, sir.
Excellent. So lambda becomes L is equal to lambda by 2.
2, sir.
This is called open argon pipe. And
Yes,
here
sir.
the frequency V by lambda, so V by 4L. And here frequency of nth harmonic is N into V by 4L. We'll get only 1, 3, 5, etc. Only odd numbered harmonics are present. In what? One end closed argon pipe.
Yes, sir.
Here the frequency of nth harmonic is N into V by 2L you will get. Because lambda by 2 is L. So lambda will be 2L here. So
Yes,
frequency
sir.
of nth harmonic is N into V by 2L. N takes all the values, integral multiples.
Yes, sir.
It is applied for both open pipe and string.
Yes, sir.
In place of string, I said a hollow pipe. That's all.
Yes, sir.
So this is the concept based on which this problem is made. So the de Broglie's dual nature and resonance were clubbed in this problem.
Yes, sir.
Mixed conceptual question we call it as. JE, very important. Even NEET also they can ask you that formula. Okay?
Yes, sir.
Yeah.
Yes, sir.
One more. This I won't do. You have to try.
Yes, sir.
The intensity of sunlight, again that radiation pressure and all. The intensity of sunlight on the Earth's surface is 1400 watt meter to the power of minus 2. 1400 watt meter to the power of minus 2.
Yes, sir.
And the mean wavelength of radiation from the sun. And the mean wavelength of radiation from sun is 6000 angstrom units. Find the photon flux. Find the photon flux falling on an area. Falling on an area 1 meter square. Falling on an area 1 meter square. Perpendicular to Earth. By assuming that
Yes, sir.
the number of photons emitted from the sun per second, the number of photons emitted from the sun per second are 1.5 into 10 to the power of 11. Sorry, find the number of photons emitted from the sun per second, assuming the mean radius of Earth's orbit around sun. Assuming the mean radius of Earth's orbit around sun as 1.5 into 10 to the power of 11 meters. You know, we call this as one astronomical unit.
1 AU. Yes, sir.
Capital AU.
Yes,
Astronomical unit is the mean distance of Earth from the sun.
Yes, sir.
Yeah, I'll tell you the method. You know, E is equal to 12,400 by lambda in electron volts you will get. Okay. Convert that into
Yes, sir.
joules. Convert that into joules. Then the intensity X is given by N by T into S E
Yes,
by
sir.
A. N by T into E by A. Therefore, total number of photons will come out to be intensity multiplied by area by energy. And number of photons, it is P by E. That is X into A by E. Same formula. So if you substitute, it will be nearly 1.2 into 10 to the power of 45 per second. Of course, it should be N by T. N by T is there already. Yeah, same formula. N by T is X into A by E. Correct? Huh?
Yes, sir.
See this formula. X is equal to N by T into E by A. You wanted N by T. So X into A by E.
Yes, sir.
So this is the answer. Simplification, you please do it afterwards.
Yes, sir.
Yeah. Please note the few problems, ma.
Yes,
For
sir.
practice, few more.
Yes, sir.
Silicon soil drop is not prescribed in the syllabus, but we'll just mention it tomorrow and just we make a reference, right?
Yes,
I don't
sir.
want to focus much on that, but just I'll make a reference of it before we begin the photoelectric effect.
Yes, sir.
Yeah. What is the relation between? What is the relation between
Yes, sir.
the wavelengths of electron and photon? The wavelengths of electron and photon, comma,
Put on. Yes, sir.
then proton and alpha particle,
Proton. Yes, sir.
proton and neutron. With equal energies, 3 bits it is. With equal energies.
Equal energy. Yes, sir.
Yeah, one more. What is the de Broglie wavelength of neutrons? What is the de Broglie wavelength of neutrons? You have to remember this formula, ma. Whatever
Yes, sir.
formula you are going to derive, solve, I say. Whatever formula you are
Yes.
going to solve will be very important and you must remember it. For proton, you have to remember. For electron, already I told you 12.27 by root V, correct?
Yes, sir.
Yeah, similarly, you should do for all the particles like this. I'm giving here neutron, you try for electrons, you try for proton and alpha particle also, okay?
Yes, sir.
So find the de Broglie wavelength of neutrons in thermal equilibrium.
Event of neutron only, no, sir.
Neutron, N, some
Yes, sir.
NEU
Yes, sir. Neutrons of thermal equilibrium.
are not of neutrons in thermal equilibrium
In thermal equilibrium. Yes, sir.
at the temperature capital T.
Temperature capital T. Yes, sir.
I gave only neutron here, but neutron, you must do for electrons in terms of temperature. You must do for proton in terms of temperature. you must do for
Yes,
alpha
sir.
particle in terms of temperature. Okay.
Temperature. Yes, sir.
Yeah.
Yes, sir.
Okay. Try them. Hmm?
Yes, sir.
Many
Yes,
all
sir.
models what are having scope in your NEET exam are attempted, right?
Yes,
So
sir.
only your practice, simplification speed will come only with practice. That is
Yes, sir.
damn sure. You must remember it.
Yes, sir.
Understand? Yeah.
Yes, sir.
So what more? So tomorrow's timing, I'll tell you. After that, we'll plan in the early morning, right?
Yes, sir.
Okay, ma. Anything more
No, sir.
to clarify, to clear?
No, sir.
Understood now what all you did today?
Yes, sir.
Yeah, practice, ma. Practice only will give you conceptual thoroughness. On reading the problem, you will get the formula and calculation speed. Everything will come with practice.
Yes, sir.
Even NEET and JE main cannot escape from what I am doing. That much assurance I can give you.
Yes, sir.
The papers will not cross what more than what we are doing here. You take it for
Yes,
granted.
sir.
You take it for granted. This is how confidently I'm able to tell
Yes, sir.
because 36 years I completed in dealing with these
Yes,
exams.
sir.
Yeah. So be
Yes,
confident,
sir.
be optimistic, practice, practice, practice. Okay. Other day also I told you,
Yes,
don't
sir.
worry about the school schedules. You make your own schedule, not only for physics, other subjects also. Divide your time allotment, make it, and sincerely work. Read whatever topics you are fixing daily.
Sir.
I'll give you a schedule for physics also, day by schedule, so that we don't stretch beyond the time. Okay. Even for other subjects also, daily be a friendly
Yes, sir.
touch with NCERT textbooks, note down all the important points in the notes, topic wise, read them again and again. Physics practice as much as possible, not new problems. Standard models, what we are practicing, same thing, you change the data. I told you other day. Here, of course, see, for example, you calculate the number of photons per second, correct? You are given energy, area, and intensity. Now, you find intensity. Take this N by T,
Yes, sir.
area, intensity, find energy. Next, take
Yes,
intensity,
sir.
N by TE, find a radius. A is equal to 4 pi r square, spherical
Yes,
surface.
sir.
So this R is nothing but this. This you have to calculate.
Yes, sir.
That's the way of practicing.
Yes,
Okay,
sir.
ma?
Yes, sir.
Shall we conclude?
Yes,
Yeah. Tomorrow timings I'll tell you.
sir.
After that we'll plan early morning as per your
Yes, sir.
preparedness. Right. Bye bye.
Yes, sir.
Okay, ma.
No problem, sir. Early morning also.
Good, good. The early morning means it will be 5 to 6. Prepare for that. Okay? 5 to 6, no problem, na?